Welcome to today's session. Today in this session we are going to deal with advanced OOP concept. So far we have learned some basics OOP concept like classes, objects, methods, etc. So now we are moving on to the advanced OOPs concept. So in advanced OOP concept we are going to learn inheritance, polymorphism and encapsulation. So these are the main advanced object-oriented programming concepts in Python language. So we will learn one by one. So first is inheritance. So as the word inheritance, it is accepting the characters, inheriting the characters from a parent. The child is inheriting some characters from a parent, that is called as inheritance. So in OOPS concept, it allows a class. The class is said to be a child class to inherit the properties and methods from another class, which may be called as a parent class. So parent class is called as a base class and child class is a derived class. So this inheritance, it helps in code reusing and hierarchical organization. In these cases, in the programs where hierarchy is involved, we can use the inheritance concept. So here parent class is the base class and child class is the derived class. So parent class means the class being inherited from. So from which class the characters are getting inherited, that class is called as a parent class or base class. The class that inherits from the base class is called as a derived class or child class. So the syntax for inheritance is class, some parent class, then we have some attributes in the parent class, pass. So again, class, child class will inherit characters from the parent class. So child class inside the brackets, parent class, then child class attributes and methods, and pass. So this will be the syntax for the inheritance. So you have to give the parent class inside the bracket. So the characters which are getting inherited should be accessed from the parent class and it should be mentioned in the child class. So here is an example to demonstrate the working of inheritance. So we have class animal. So animal is a common class. So this is considered to be a base class, that is parent class. Then after assigning a class, we have to use the constructor for initiation. So always we use the init method. So this define init method self comma name. So self dot name is equal to name. So these are the assumptions we have already seen in the previous sessions. Then def speak of self. So this is another attribute. So define speak of self. Print self dot name makes a sound. So this contributes to the parent class. So next comes the child class. So class dog of animal. So this will be a child class and this will be a parent class. So this is considered as a derived class. So in the derived class, we mention both the child and the parent class. So now diff speak self. Inside that speak, we print self dot name bark. So now dog is equal to dog of Buddy. So here Buddy will be the self dot name. So dog speak. The output will be Buddy bark. So self dot name is accessed inherited from the animal class. So when we are mentioning as Buddy, it will go and store it in self dot name, which is inherited from the parent class. So as per the statement, dog is equal to dog of Buddy. So child class of parent class. So parent class attribute will be executed here. So Buddy barks, that will be the output. So this is an example of inheritance. The next is the polymorphism. So polymorphism, poly means many. So morphism means it will take several changes. It will have many forms. So that is the polymorphism. So polymorphism allows methods to perform different tasks based on the object that calls them. So it will it will take many forms and perform the task whenever it is called. So polymorphism means many forms. So it is achieved in two ways. So one is method overriding, another is method overloading. So method overriding means the child class, it provides a specific implementation of a method that is already defined in the parent class. So uh, when it is already defined in the parent class, you can assign some other um, object onto it that so that it will take another form. So this method is called as method overriding, and another is method overloading, which is a default method that will be achieved using default parameters in Python. So taking many forms is said to be polymorphism. So here is an example for polymorphism. So here a parent class is assumed here, that is class shape, a shape of diff area self pass. So this will be the parent class, and the subclass is child class, which will be class of rectangle of shape. So inside the rectangle class, we will give the area formula for rectangle. So which is L into D. So we will define these width and height. So the definitions are given here. So when calculating the area, depth area of self, return self dot width into self dot height. So it will return the area of the rectangle. Similarly, another child class of circle of shape. So now this parent class, it is used in both the child classes. No child classes, we have two child class, one is rectangle and circle. So inside the circle child class, we use the area formula for area of the circle. So after assigning the both the classes, we go for shapes is equal to rectangle 4 comma 5 comma circle of 3. So now for shape in shapes. So this statement denotes that the child class takes many forms, that is a rectangle or a circle. So this is termed to be a polymorphism. So for shape in shapes, print shape dot area. So whichever shape is assigned, that area, that class will be executed and it will be printed. So this child class takes many forms and it gets implemented. So this concept is called as polymorphism. The next is encapsulation. So encapsulation means protecting the document from the usage of the other users. So that means it also refers to restricting the access. So this access will be, suppose if you are planning to use the document only by few people, the access should be given to only those people. The remaining users should be restricted from the accessing the file. So in that cases, we will be using the encapsulation techniques for restricting the access to only the certain details of an object. So we have three methods of restricting the access. One is public attributes, protected attributes, and private attributes. So public attributes means it can be accessed by any people from anywhere. That is the public attributes. And protected attribute means it should not be accessed directly outside the class, but it is accessed inside the child class. So this access is given only inside the child class but not outside the class. So this will be protected attribute. So when giving protected attribute, the syntax should be like this. You should use a single underscore then attribute. That is a protected attribute. And private attribute, it is accessible only within the class. So private attributes, it is accessible only within the class. Outside the class, nobody can use the attributes. So this can be denoted by double underscore followed by attribute. So these are the two methods of encapsulation. So by these two methods, protected attribute and private attribute, you can restrict the access of that particular object. So we have an example for encapsulation. So here we have a class called as employee. So inside the employee class, we are defining name and his salary. So self-dot name equal to name, which is a public attribute. So here we didn't use any underscore, so it will be a public attribute. This is not encapsulated. And next we define the department using self dot underscore department equal to HR. So this is a protected attribute. So this is used only within the class, not outside the class. And also it can be accessed with the it can be accessed if the uh, access is given, and self dot double underscore salary is equal to salary, which means it is a private attribute which cannot be accessed anywhere or by anybody. It can be accessed only inside the class. So def get salary of self return self dot salary. So then emp equal to employee name and salary are stored here. So while printing emp dot name, since name is a public attribute, it will be printed, and print emp dot underscore department. So it is a protected attribute. So that will be printed here, and print emp dot get salary. So get salary is a get underscore salary. So print of end dot get salary. So output salary will be printed. Print end dot double underscore salary. So here we have double underscore of salary. So since we are using double underscore, so here we have used single underscore. That means it's protected attribute. Here we are using double underscore. So we cannot access this and that salary outside of the class, so that it will lead to an error called as attribute error. Employee object has no attribute salary. So here you can see in employee, this employee object is showing that it does not have any attribute called as salary, since it is private attribute. So this way you can hide the access of any object in the class. So this is an example for encapsulation. So now we will move on to the Python editor, and we will try to solve some programs. So now let us see an example for inheritance. So for that I am defining a parent class, which means dad, this family. Also always define a self attribute here, self argument. So dad is having money, print dad's money. So this will be the parent class. Now I'm writing a child class. So class son of. So initially I'm defining only the child class. Define. So son is having mobile. mobile itself. Print son's mobile. Now I'm creating an object called as Raj equal to son of Raj dot mobile. So I'm creating an object for son. Then I'm calling the object. I'm calling the object with respect to the function. Now I have to get the output as son's mobile. Let us check it. Run module. I'm saving it as inheritance. Inherit. So I'm getting error as name error. Name son is not defined. So it is asking whether it is capital S-O-N. So yes, it is right because I have defined it as S-O-N with S in the uppercase. Now I have rectified it. Again, run the program. So I am receiving the output as son's mobile. So So now I am, so simply it is working like this. So now I'm going to inherit the uh, parent attribute in the child attribute. So am including a parent class here. So son of dad. So we have a son attribute here. Now I'm calling Raj dot money. So we will check whether it will work or not because Sun has mobile, so automatically it gets printed. Now I'm asking for Sun's money. So since we have inherited the attribute from a parent to the child, it should be printed as dad's money. It should be accessed by the child class also. Now let us check. Yeah. So the output is dad's money. So from this we can understand that how the inheritance is works. Now I'm adding another parent class which may be mom class of mom. So inside mom I'm defining food, food of self, print mom's food. So now I am inheriting both the dad and mom attributes to the son attribute. So get I should be able to access the mom attribute also. So Raj dot food. So let us see if both the parent class can be accessed or not. So I'm getting dad's money, mom's food. So this means the child has inherited both the characteristics of dad as well as mom. So this is how we can understand the inheritance concept. Similarly, if you use this kind of syntax, if you are defining the parent class with the child class, you can be able to inherit their attributes. So this is an example for inheritance. This type of inheritance is called as a multiple inheritance. So Simply when we are using only dad's attribute, we that kind of inheritance is called a single inheritance. And now we are using both the parent attributes. So when we are using more than one parent attributes, that kind of inheritance is called as multiple inheritance. Now we will see multi-level inheritance. So here we have dad class as a parent class. Now mom is accessing dad class, whereas son is accessing mom's class. Okay, so now dad is a parent class for mom and mom is a parent class for son. So now this son will be able to access mom's attribute, which is food, and that will be in turn he will also be able to access dad's money because mom is accessing the dad's attribute. So this kind of inheritance is called as multi-level inheritance. So now let us see how it works. So I am simply giving Raj.food. So since he is accessing the mom's attribute, it is printed as when we are accessing the mom's attribute, the output is mom's food. Now let us try to access the dad's attribute, but here we hadn't uh, defined, used, inherited the dad's character, but it should come from the previous level child class. So I'm now calling the object Raj.money. So now I'm getting mom's food and dad's money. This mom's food is the output for Raj.food. So I'm removing this and now I'm checking. So now I get the answer as dad's money. So you can understand that son is inheriting mom and mom is inheriting dad. That's why son can also inherit dad. So this kind of inheritance is called as multi-level inheritance. So next is polymorphism. So to explain polymorphism, we will take a program. I'm just defining a object diff add a comma b, print a plus b. Now add. So I'm just running the program. I will. So it asks for some input. I'm just entering it as 10. So it is printing whatever values I give. So therefore you can see that there is some error in the program. So I'm giving the variable 10 comma 20. So this 10 will be assigned to this 10 will be assigned to A and 20 will be assigned to B. Therefore, the output will be A plus B, that is 30. So we have got the output as 30. Now I'm adding another variable called C and the formula will be A plus B plus C Now I'm running the program. So we have an error called type error and missing one required positional argument C. So since I haven't defined the value here for C, I assume three variables but given data for only two variables. Since the constant for value of C is not defined here, it shows a type error. And therefore, I'm assigning C is equal to 0 in the definition. So I'm giving A is equal to 10. 10. I'm printing A. I didn't give any value to the add. So I'm just printing it. So the value is 10. Print A, that means 10. So now I'm writing 50 here and passing the value. So it printed as 50. So A assumed 10. A assumed the value of 10. So printing A, so it have printed 10. Now add of 50. That means A has assumed another value, a new value that is 50. Therefore 50 is printed here. Similarly, if I give 100, that will be printed here. So we can see that A for a single program, it takes many forms, which is known as polymorphism. So if I remove this value, so we don't pass any value to add, that means the 10 will be defaultly it is printed. You can see 10 is printed here. Now I am changing this assumption as A comma B comma C is equal to 0. Now A will be A plus B. Now I'm passing 1 comma 2. Add of 1 comma 2. I didn't give any value for C. Now in the next statement I'm giving value for C. So initially what it means is in this while executing this line C will be assumed to be 0 because it will take the default value, but while executing this line the value of C is passed here, that will be transferred to C and the corresponding output will be received. So why this error comes is because in the print statement I have missed out C. So I'm giving C here. Now in the first statement 1 plus 2 3 will be the output. While executing the second line 1 plus 2 plus 3 6 will be the output. So you can see 3 and 6. So this means for this line C takes the value of 0 since no value is given here, and while in this line the value of C will be passed as 3. So this is called as polymorphism. So this the same function. So we have a same function add, but we are using it in two different methods. So here I am using it for adding two variables, and also this is for adding three variables. The same add function will take so many forms. That is why it is called as polymorphism. So this add function is used for performing two activities. So that is called as polymorphism. So next concept of book is encapsulation. So we'll see how encapsulation works. So as we had already seen, encapsulation means restricting access to some objects. So now we'll start a program of demonstrating encapsulation. Class company diff init, create a constructor here. Self dot company name equal to Toyota. So I'm creating an object for this C1 dot company. Print of print C1 dot company. C1 dot company name, so that it will take the company name from here. Here C1 dot company name equals to Toyota. So now print C1 dot company name. So when you run the module, you will get the output as Toyota, the company name as Toyota. Now somebody from outside can change your company name. Like for example, Honda. So now if they are changing like this, so your company name will be printed as Honda. So now I don't want to make others to access this company name. So what I have to do is I have to make it as a protected or private attribute. So, so I'm going to use the access modifier. So access modifier means we have already seen that single underscore or double underscore. So these are called as access modifiers. So now I'm using double underscore company name. So here also I'm calling the same function. So it should be Toyota and not Honda. Now I'm running the module. So I'm showing an attribute error. So it is showing us it has no attribute. That means it is a private attribute. So the system cannot able to detect this private attribute. So this kind of using the access modifier will protect the document or data object from the other users. So by using these access modifiers, you can make your object as private or protected. So this is how you can encapsulate a data. So this is about using inheritance, polymorphism or encapsulation concepts in Python programming. So now we will go to an real world scenario example. So implementing OOPS concepts in real world scenarios. How will you implement these inheritance and other concepts in the real problems? So for that, I have taken two problem statements. The first statement is to develop a banking system where different account types like saving or checking account inherit from a base account class. So here we can understand the full concept of inheritance. So here what the problem statement says is this account class should be a base class or parent class, where the saving and checking account should be a child class. So it will be a multiple inheritance method. So we see the program for this. This is the layout of the program. So now let us see how it works. So here in this program, we are going to explore and work on a simple program that simulates a real world bank account system. So in this program, we will be able to understand the key concepts such as classes, objects, inheritance, and methods. So in this program, so as we have already seen in the problem statement, we have to build two types of accounts. One is the account, that is a base class, and savings account. So base account is a that is a basic account that allows deposits and withdrawals, and another one is a savings account which is specialized uh, to store the interest upon the balance. So that is the savings account. So first we'll create a class called as account. So for that I'm creating a class account def. So I'm using a constructor to initialize def self self account holder comma balance. So initially I'm assuming the balance to be 0. Self dot account holder equal to account holder. So this will be the name of the account holder. Then self dot balance is equal to balance. This will be the balance that is present in the account. So here I am using the constructor. So this init method is one of the method constructor that runs automatically when we create an object of the class. So here it initializes two important attributes, that is instant attributes, because we are using self here. When we use self, these attributes gets converted into instance attributes. So one is the account holder, so the name of the person who owns the account, and another one is the balance, so initial balance. So this will be the initial balance which is defaultly set as 0, and now so this will be the my parent class account. So now I'm going to deposit or withdraw from the parent class. So I'm creating another class for depositing. So class for def deposit. So for deposit, I'm depositing some amount into the object. So if I deposit some amount, then self dot balance, my balance will get increased. So self dot balance plus equal to amount. This means this amount that I am depositing will be added up to the previous balance. So that is the meaning for this plus equal to. So return self dot balance. So this deposit method, it allows the account holder to add money to their account. So self dot balance plus equal to means it adds the specified amount to the existing balance and then it returns the updated balance. So and next is after deposit method, we will do the withdrawal. So withdraw, def withdraw, self comma amount, self comma amount. So while doing withdrawal, we have to check the balance. So if amount is greater than self dot balance, if what I am withdrawing is greater than my balance, it will print as what it will print usually insufficient funds. Insufficient funds else. So else means if my amount is less than the balance, it will reduce the amount from my balance. So self dot balance will get minused. That means subtracted from the amount. Will be subtracted from the amount. Then you can ask for the return self dot balance. So now the withdraw method allows the account holder to withdraw the money from the account. So as we have two cases here, it will check for the amount which is greater than, if it is greater than the balance, it will print the insufficient fund, else it will reduce the amount from the balance and it will return the balance, new balance value. So then the next part is to create a savings account class. So this is my basic account, that is a parent class. So inside account I have the two functions for deposit and withdrawal. Now I am going to create a savings class. So class savings account of account. Def so initializer using a init method. Init self account folder, then balance is equal to 0 as usual, then interest rate, because savings account is used to earn the interest. So interest rate is equal to 0 0.5. So this is initialization. Next I'm using the super keyword, super dot init account folder, comma balance. Self dot interest rate is equal to interest rate. So this savings account will inherit from the account class. So this means the same method it can access like deposit and withdraw. So it can also have the access for depositing and withdrawal, and also it has its unique attribute called as interest rate. So this super method, so why we are using this super method is This super keyword will call the constructor of the account class so that we don't have to write that part again. So it initializes the account holder and balance just like the parent class. So this super keyword, it also create a new attribute called interest rate. That means the savings account will create new attribute called interest rate. So which is have been set as 0.5 by default. So this is about the savings, initializing the savings account. So after initialization, we have to define the add interest object. Add interest self 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 dot balance equal to. So whenever interest is generated, it will get added to the balance. So self balance into self dot interest rate. So this add interest method calculates and adds the interest to the balance. So the formula will be new balance is equal to current balance plus self balance into, that means current balance plus current balance into interest rate. So that I have defined this thing in the formula. So now we will check how this program works. You can create a program for a parent class and child class, and you can use the print statements to see the balance, and you can add the account holder name and balance. You can deposit and withdraw. So this is how you can create a real world problem. So you can create, we have given two problem statements for this session. You can write a program in this way to solve the problem, and you can try arriving at the output.